inspirations for this conference was my visit to Chattanooga, Tennessee, and Gig City Elixir. Not only was there a NERDS Conf, not only was there an Elixir conference, and not only did it collect some of my favorite people in a single place for several days of deep nerd shit. It was even a small city that punches above its weight in terms of interesting things to see. The similarities are frankly eerie, but it's only because I completely stole the formula. It did have something going for it that I could not copy by myself. It had Bruce and Maggie Tate. These two are incredibly generous, great fun, and important contributors to our community. They're aggressively welcoming. They're ridiculously generous. They're very fearful about feeding too hot food to sweets. It's not that hot. It's fine. And they are proactively inclusive, which you'll see if you ever go to their conference. And they're absolutely, doggedly determined to help. So it's very hard to replicate. I'm not that nice, personally. Thankfully, they could make the trip over here, and you'll see Maggie helping out around the conference, and you'll see Bruce right about now. He wrote the book that introduced Jose Valim to Erlang. He cannot be thanked enough for that. He's the most prolific author in Elixir. Welcome to the stage, Bruce Tate.
What do I say to that? And does anybody want to give a talk? Because I feel like I have to follow Sasha, and Flora, and Andrea now. And by the way, you saw Andrea's talk. There's no robot on the planet that could do this. Come back up. Lars, take a bow. This is great. Remember where you are right now. This is great. Thank you very much. This, contrary to what Andrea told you, this is an AI conference. I'm going to sneak some Elixir in. I am really going to talk about the idea of large language models and the idea that languages and tools shape the experience, though not the way that you think. We've been told that since there's so much training data in Python and JavaScript and Java, that Elixir doesn't have a chance. I don't think that's true. So I want to steal some ideas from a keynote that I gave with Josh. Josh, are you here? Thank you, Josh, for sharing the stage with me at ElixirConf. But I want to talk a little bit about my journey and kind of riff on some of the ideas that we put out in an ElixirConf talk. And I want to take those a little bit deeper with this talk. That's the extra time. Thank you, Andrea. So my talk started with the Java programming language. How many applause if you started with Java? Okay. Okay, do you remember this word called Pojo? Which is a frightening word, right? Because it's a 4-letter acronym, 1, 2, 3, 4, for the most basic concept in the language, right? Plain, ordinary Java object. And that's nuts. So my career started with Pojos, but it didn't stay that way for very long. And it's been about 5 years, maybe a little bit more, since I've spoken in Sweden. But has anybody been to the Vasa Museum? So this is Java. Tell me I'm wrong. You start with a ship, then you start adding these sculptures, more sculptures, and then a few cannons, and we have to have the bestest, the mostest cannons. And so you sail that ship right off, and it sinks to the bottom about a mile away from shore. Right? And for the purposes of this talk, these are the same. Because LLMs are built with a training loop. and these loops depend on the data. So an LLM is nothing but a function that predicts an answer one word at a time. Right? So for the purposes of this talk, I'm going to talk about a function like this. This isn't really how it works, but you take in a prompt and you spit out an answer. Really, we're spitting out one word at a time, and we're peeling off one word from the back of the model and then adding another word on the front. Okay? But there are these constants. And initially, you start with a large language model. You hold those constants, or you hold the variables, the prompts. You make those variable. And you tweak the constants over and over until you get the answer that you want, right? So we change the constants to predict different answers. And I start with some training data and some testing data, which today is basically the internet, right? And then I start tweaking the constants until I get what I want, right? So one step, and then another, I tweak the constants. But the thing is this, that a good answer is not a good program. A good answer is something that looks like another program on the internet. Right? So the old programs are going to shape the new programs. Is this good? Sometimes it's good. Okay, so imagine my career in this language that's getting more and more bloated. I'm having to introduce these new concepts because I'm a trainer. I have to introduce these new concepts to people that want to enter the community, and maybe they don't even know what an object is. And so I have to introduce them to Java. So often I would say, start with this stack of books. And you would start with some type of a Java programming book. And then you would move to the user interface. You would have this struts book and a JSP book. And then you would kind of move up to a level which maybe is an enterprise Java Beans container. Or maybe it's a dependency injection container. And then you would layer on top of that with entities and sessions and queues. So I moved to the Ruby language. And I found that I loved Ruby because I found that the stack of books was too high. Just two. Not T-O-O, T-W-O. Right? Programming Ruby, programming Rails, done. And this worked. And the reason that it worked was because I was on Rails. Right? And Rails means that there was a pre-contained or preconceived notion of the thing that I wanted to build. It was a relational database with a big fat web UI babysitter, and that was it. We built this application over and over and over. Right? And sometimes, after a little while of building this is what the internet boom back in 1999 was based on, right? This idea over and over and over. But sometimes we had to, the customers would offer more. So what we did was we gave the customers 3 metaphorical blue chips. Now, in the United States, the blue chip is the highest denomination of a chip at the poker table. And we would give them 3 chips to spend on whatever they want. And they could build as much as they wanted of the relational database with a big fat web user interface on top. And we would successfully build this thing. Right? We had this beautiful foundation and a little bit of a rickety application. But it worked. It was good enough, right? And the customers were thrilled because they didn't have to pay very much for the application. But then customers started to ask for more. Maybe it was more blue chips. Maybe it was bigger blue chips. We were taking a walk yesterday, and imagine my surprise when we saw this. of amazing, right? So the customers negotiated and negotiated and negotiated until something bad would happen. Right? Because sometimes when you're thinking about the abstractions and shaping your business around the abstractions that the framework needs, you're not thinking about the what your customer needs instead. So fast forward to today, and I believe that the agents have a very similar problem, right? Because this is what things look like. It kind of looks like a gen server, right? We have a state and a reducer. We feed a prompt in, and then we get another state. And we do this over and over and over. But here's the thing. The accuracy suffers with each iteration. When you're wrong, like such as stepping outside of an abstraction that your framework expects, you lose a little bit every single time. So the LLMs are great when you're on the rails, but when you come off, things change. So, when I moved to Elixir, I had many of the things that I loved about Ruby. I felt like I was on Rails, right? Because it did the same things very well. I also got a lot of the enterprise frameworks that I have with Java, but without the corresponding bloat. It was also immutable. And by the way, if you want to improve your experience with an LLM, one of the things that you can do is spend more time in the functional core because the models are great at that. It will rarely miss. But the tooling also makes for a better experience on the models because we have not just the tooling for great documentation, but we have the culture of great documentation. We also have self-healing services, and this isn't going to make sense for you. But in those tires, we took this long boat ride, and we carried these folding bikes. And in these tires, we had sealing, right? And we never had to worry about patching a tire on the Great Loop. And when it came time to attack problems in anger, I didn't have to worry about the blue chips because just like this dry stacked centuries old samurai wall, every step that I got closer, the pieces fit together a little bit better. I found that the abstractions were like stones, like the OTP stones that fit together with concurrency and in a self-healing way. I found that I had plugs and contexts and lambdas and libraries and all these open source types of tools. And I had pluggable types that were protocols. I had pluggable modules that were behaviors that gave me inversion of control. What I really had was flexible abstractions that let me fit more blocks together in a predictable, maintainable way. So if you think about the training loop, the abstractions are everything. First, if you do make a mistake, the stability is going to matter, and you have OTP underneath you. And also, I want you to think about the ideas that come with the language of your choice that you might compare to Elixir. Think about all of the build tools underneath JavaScript versus Mix. Think about all of the different web component and frameworks versus Phoenix. Think about JavaScript concurrency and run-to-completion semantics versus OTP. And now let's think about the agent loop for a little bit. Think about what Phoenix looks like, the dimensions of extension versus the same ones in Elixir. And so I want to make a case for Elixir that we have the self-healing services, that we have the immutability, And I want you to imagine if you're an LLM and you have to write a test for an application that is going to be using a service like a counter a lot. Right? You might call this the increment on this counter hundreds and hundreds of times. So think about testing that plus versus testing a counter with state. It's a vastly different thing. But I don't want to stop there. I think that we're going to see greater and greater importance on frameworks that give us structure applied in a uniform way and applied in a way that give us more generation and determinism. So I want to make a case for Ash. So if you think about two dimensions for skills, one of them is coding. Basically, the longer you spend as a programmer, the better that you get at it. And I want to think about this as determinism. So in the Elixir Conf talk, Josh expressed it this way, as it should, as a function. One input gives you one output. And these are the programs that we can write with Elixir. Right? But there's another set of skills that's prompting. And this gives us, sure, great productivity, but it also gives us non-determinism. It also gives us non-determinism. So that we have an infinite number of inputs and an infinite number of outputs, and that makes the results both random and dangerous. So I believe that what Ash gives us is effectively the best of both worlds. And so if you haven't seen, I'm going to give you just a very brief review of Ash. If you haven't seen the basic idea. So it's basically the whole iceberg is your application. The top is what you want to build. The bottom is what you need to build. And all of the things that you associate with value are on the top of the waterline. And all of the things that you associate with cost are below the waterline. So that at the top is the core, and at the bottom is the waste. So looking at this another way, I have a layer in the middle. That's what you want to build, your domain. With Ash, that's where you spend the time. And you can generate much of the rest. Okay? So if you think about it, if I'm building an application with an LLM, every time I press generate, I get something different. But I start with this tiny little prompt, right? Now with Ash, I have to put in more work. On the left-hand side, I have to specify the whole domain. I have to specify, and on the right-hand side, all I need to specify is my prompt. That's going to change with every turn of the crank on the left-hand side. But what we really have is the determinism versus non-deterministic. Said another way, we have these stable blocks on the left-hand side, and we have unpredictable on the right. So what Josh said in the keynote in Orlando was that we can get the best of both worlds so that we can effectively start with this picture and use determinism around the edges. So I know I'm between you and lunch. I know that I'm sneaking in AI into an Elixir conference, so I'm going to end a little early. But I want to say, and I want you to get this, that I believe that Elixir is uniquely suited for this moment. Because we have the protection from instability. We have the immutability and the abstractions that help LLMs reason. And you're starting to see that expressed in papers and expressed in people having success with this particular language. We have determinism and non-determinism both when you need them. But what I really want to say is that we're going to be okay. You're actually going to thrive. Now go build something